What if I told you that everything you see around you, your room, your phone, even you, might just be a projection, like a cosmic hologram? And the craziest part, science is actually backing this up. Today, we're diving into one of the most mind bending theories in physics that's going to make you question literally everything. We're talking about the holographic principle, the idea that our entire 3D universe might actually be encoded on a 2D surface. And trust me, by the end of this video, your brain is going to be doing backflips. All right, let's start with the basics. You've probably seen holograms before, maybe on a Pokemon card or your credit card. When you tilt it, the image seems to pop out and move around, right? Here's the wild part about holograms. All the information needed to create that 3D image is actually stored on a flat 2D surface. The hologram contains all the information about the 3D object, but it's compressed into fewer dimensions. Now imagine if you could cut that hologram in half. Guess what? You'd still see the complete 3D image in each piece, just with less resolution. The entire 3D information is distributed across the whole 2D surface. Keep this concept in your head because we're about to scale this up to the entire universe. Okay, think of it like this. Imagine you're inside a giant sphere. According to this principle, everything happening inside that sphere, every particle, every interaction, every bit of information, could theoretically be encoded on the 2D surface of that sphere. But wait, it gets crazier. What if that sphere is the entire observable universe? What if everything we experience in our 3D reality is actually just information encoded on some distant 2D boundary? This isn't some random sci fi idea, guys. This principle emerged from serious physics research, particularly from studying black holes, and the math actually checks out. The wild implication is that you, me, this video, your cat, we might all be projections from information stored on a 2D surface at the edge of space. We're basically living in the ultimate hologram. So, how did scientists even come up with this crazy idea? It all started with black holes, those cosmic monsters that eat everything, including light. Back in the 1970s, Stephen Hawking discovered something weird about black holes. He found that they emit radiation and actually evaporate over time. But here's the kicker. The entropy of a black hole, which basically measures how much information it contains, is proportional to the area of its event horizon, not its volume. Wait, what? That's like saying the amount of stuff you can fit in a box depends on how big the box's surface is, not how much space is inside it. That makes no sense in our normal 3D world. This discovery led physicists Jacob Bekenstein and Stephen Hawking to propose something revolutionary. Maybe the information isn't stored in the 3D volume at all. Maybe it's all encoded on the 2D surface. Then in 1993, physicist Gerard Hooft took this idea and ran with it. He proposed that this might not just apply to black holes, it might apply to all of space. And that's how the holographic principle was born, the idea that our entire universe might be a hologram projected from its boundary. Now, you might be thinking, this sounds cool, but where's the proof? Well, that's where things get really interesting. In 1997, physicist Juan Maldacena made a breakthrough that changed everything. He discovered something called the ADS-CFT correspondence. Don't worry about the name, just know it's huge. Basically, he showed that certain theories describing gravity in a curved 3D space are mathematically equivalent to theories on a flat 2D boundary. It's like having two completely different languages that describe the exact same reality. This was the first concrete mathematical proof that the holographic principle could actually work. Suddenly, what seemed like science fiction had solid mathematical backing. Since then, thousands of physicists have been studying this correspondence, and it's led to breakthroughs in understanding quantum gravity, black holes, and even the nature of space and time itself. The craziest part, the math suggests that the holographic description might actually be more fundamental than our normal 3D view. Like, the hologram might be more real than the reality we experience. Okay, so let's talk about what this actually means for us. If the universe is truly holographic, then literally everything about your existence, every thought, every memory, every interaction is encoded as information on some distant 2D surface. Your brain processing this information right now, that's just patterns of data being processed on the boundary of space. The fact that you feel like you're a 3D being moving through 3D space, that's just how the hologram appears from the inside. It's kind of like being a character in a video game. From your perspective, you're moving through a 3D world, but actually, you're just information being processed by code running on a 2D computer chip. But here's what's even more mind blowing. If this is true, then the concept of inside and outside becomes meaningless. We're not really inside a hologram looking out. We are the hologram. And get this, some physicists think this might explain why quantum mechanics is so weird. All those strange quantum effects might just be artifacts of how information is encoded and processed on the holographic boundary. So, where does this leave us today? Well, the holographic principle is still very much an active area of research. Scientists are trying to figure out if our actual universe works this way, or if it's just a cool mathematical tool. There are experiments being designed to test whether space itself might be holographic. Some researchers are looking for holographic noise, basically pixelation in space-time that might show up in ultra-precise measurements. Other scientists are using the holographic principle to better understand black holes, quantum gravity, and even the Big Bang. It's helping us answer some of the biggest questions in physics, and who knows, maybe in the future we'll figure out how to actually read the information on the boundary. Imagine being able to access the source code of reality itself. So, there you have it. The universe might literally be a hologram, and we're all just information patterns dancing on a distant 2D surface. Pretty wild, right? This is exactly the kind of stuff that makes physics so incredible. We're not just studying rocks and planets, we're questioning the very nature of reality itself. If this video melted your brain as much as it melted mine, definitely give it a like and subscribe for more mind bending science content. And let me know in the comments, do you think we're living in a hologram? What would that even mean for free will and consciousness? Thanks for watching, and I'll see you in the next video, wherever that might be encoded. See you soon.